All right. Welcome everyone to AI Frontiers meetup. We meet here every couple of weeks. I think this year we are going to start more frequently. My name is Junling Hu. I'm the organizer for the meetup. I'm also speaker for today's meetup. Um, if you are new, check out our Meetup page and also our YouTube channels. So I'm going to give you the link you can check out. Let me share my screen and you will see the information there. Just one moment. Just let me first put that in a more presentation mode. Okay. Uh, all right. So we are sharing this. Let me put in the screen. All right. So we do have a YouTube channel. If you cannot make for the event, you feel free to check out our YouTube channel. I encourage everyone subscribe. We have more video job, in addition to our normal talks. For example, I just made the AI singer, which is very interesting. You can make the AI sing and create a song from beginning with everything from the lyrics to music to singing, and then um, do the lip sync with the character you created, also with AI. So from end to end, it's AI. And if we have time, I'll show you how it looks like. Also, I may drop some tutorials on other things like how to build agent, other informations. So feel free to sign up. So it's underscore the underscore AI Frontiers. It's a new channel. The reason is we want to restart this year on all the major topics we're talking about. All right. So today's topic is about the agent, and we will have some time at the end. We will have discussions. I believe many of you already built a very advanced agent, so it's a great time for us to share the experience and what kind of things we can build. I will share with you two apps I built with agent. Those are the small apps, but you can see how easy it is to to use agent. For today's talk, the focus is more on the AI technology. What is the principle behind building agents? So many of you are actual developers and also researchers. So this might be interesting to see how we can build sophisticated agent. All right. So let's talk about the major inflection point for 2025. We know 2025, actually I would call it the year of agent. 2026 is actually the starting year of robot. By 2025, agent already become more mature. I would say already mature. So I will show you the example, and many of you probably heard the news about um, the cloud co-work from Anthropic, which is amazing. They just do all the file organization for you. They essentially go off do their own thing and basically not just take the instruction, they just somehow take initiative and do combine many different tools together to deliver the result. So that is what we are going to see, and that is actually becoming mature and become product. That's why Manus was sold to Meta, and I will explain why that's the case. The major shift is enterprise adoption. So in 2025, companies before in 2024 is still a concept, but in 2025, every company see, particularly large enterprise company, see agent become actually a cost saving, productivity improvement, and actually can really increase ROI. And also in 2025, we see a major shift of agent going beyond to become just some tool execution, like fetch something, go out to do something. So they're beyond that. The agent now is seen as with state, memory, and autonomy. Then that becomes more obvious when we build a more sophisticated agent. So to be make it more concrete is in 2023 is more RAG. People talk about the retrieval, getting the document processed to answer good questions. 2024 tool calling become introduced and become a big trend. Every agent supposed to be able to do tool calling. 2025 is where all the framework for agent become mature. When we say framework, is more about a production lies of the agent development. And so and also, in the beginning, in the end of 2024, we introduced so-called Copilot. And you have Copilot for coding, Copilot for summary, Copilot for something sitting on the right, and you can ask question, maybe even doing SQL agent. Those are like working with you. However, data is coming to the end because we're seeing an end-to-end agent execution to actually just do the whole thing for you. And so that's becoming the trend. Lastly, I want to mainly focus is so-called context engineering. We have moved beyond the prompt engineering to context engineering. This is a major technical trend for agent. And so to just um, I think this is probably a very familiar chart picture for most of you who are building agent. Is essentially agent is using LM to do the reasoning on what to do or to how to respond. In doing so, they access RAG documents, they access data, they access user history, and then use some tools to call MCP server. This whole end-to-end process is what we understand about the agent. However, it's not sufficient to really deploy your agent. This is where a framework comes in. So what is a framework? Framework is where we can swap out the model. We can easily integrate tool calling through MCP. We can manage the state and the memory. We have a guardrail for handling error, and also we can have a multi-agent framework to handle to dedicate work to different kind of agents. And finally, we have observability and evaluation pipeline. So I mentioned this a little bit in the last talk when we summarized 2025. What I want to emphasize is if you are deploying agent in 2026 and a framework is a requirement, it's not nobody can almost no company if you are building startup, if you are even write a simple agent, you would like to really establish your agent in a framework so that once you have a framework, then um, all the everything will be integrated together, become a coherent deployment. Instead of like in 2023, we are writing a simple agent, even though you are defining like inheritance, but it's very ad hoc, right? So 2024, certainly we pay more attention to tool calling, pay some attention to evaluation, but it's not integrate together. So in order to really deploy production agent, we have to think through all the major components that's required for deploy a so-called agent. And because not only you are build in the production, your agent could encounter some unexpected problem. So you would like version control of your agent. You need to roll back. You would like to monitor how the agent does over time. So you need evaluation and real-time feedback. You also want to be able to improve the agent through the changing the prompt. But how do you change and how much to change? All those come into play once you have a production agent. So this is a constant iteration. So that is what the people now realize we have to pay attention to. Okay, so now let's move to the next slide. Oh, why is that? I cannot. Okay, all right. So certainly there are many frameworks to choose from. In the industry, we have the oldest Nanchain and the Nangraph. Nangraph is a product of Nanchain, specifically designed for agent. There is Crew AI that's started early, starting I think it's 2024. Then Microsoft AutoGen, Llama Index, these are very popular open source framework. In early 2025, OpenAI jumped into this basically the fray. Everyone is doing this. Then Google, in the middle of 2025, Google released ADK. Amazon, end of 2025, released their stack. I believe it's called Nova. So, as you can see, essentially, I believe as I mentioned in the previous talk, in last week's talk, the older the open source model gradually lose favor if you actually deploy your agent on those cloud. If you're on Amazon, you want to use their native agent framework. If you're on Google, you want to use Google's. If you integrate with OpenAI, you want to use OpenAI's agent SDK. There's a lot of underlying runtime agent call optimization has go into their framework. So we want to take advantage of the cloud native framework. And so there, actually I wrote blog about why that, what advantage that gave you. So it's very, very obvious. For example, if we are using Google Cloud, you have all the files, you have um, other like Google model calling you. So you have a lot of components that's dependent on the cloud. So the framework will be very seamlessly integrated with that cloud environment. And what that suggests is it's no longer a unique so-called framework. Every company can write their framework. Every platform can write their framework. It becomes more like a commodity. So it doesn't matter what framework. Personally, I believe it doesn't matter what framework you adopt. You just want to be efficient in using that. Um, okay, we have a comment. The so if you have a framework regarding Jack Ruth's question, if you have a framework, sorry, let me. If you have a framework, you have a choice. They allow you to select different models, so you don't have to um, tied to one model. You also framework doesn't solve the problem of weak model. The model is still fundamental. Model is the intelligence. It's like the brain. The model is like your arms, your legs that help you to move, right? So the framework. I'm sorry, the framework. The framework is the orchestrator, right? So it's put everything together. The model is the center where it reasons, it decides what to do, how to call the tool, how to respond. Those are the relationship between model and the framework. Um, okay, I think I moved into technical too fast. I want to actually share with you a more I'm going to talk about this prompt self-improvement, but I want to share with you more on the high level. I wrote a separate document. I want to share with you some high level summary about last year before we dive into very technical details. The because there are a few more things I want to mention regarding the major the major agent uh, the major agent development. So this is a separate um let me see. How do I maybe I put this in the presentation mode. Yeah, okay. Let me share this with you. Okay. So I generated a separate slide based on the content, but and you can see Manus actually helped me write the slide. I wrote the content. They make it beautiful. There are many slides. This is actually I want to talk about why Meta achieved. Originally, in my previous talk, I thought Manus didn't do any special things. They certainly are very good. When I early last year when I tested Manus, it was just able to do sequential task completion. But since then, they matured much more. When I was actually very surprised with their many function Manus provide. They can take a PowerPoint bullets, all the content, and then create beautiful slides for you. The what that means is many companies specialize in slide creation. Many startups probably will go away. We have AI PPT. There are beautiful AI. There are many slide creation startups. But if Manus keep continue this trend, I would see many people, those startup will lose out to this general purpose. As I mentioned, general purpose app building agent will become dominating. All right, so let me share with you what I summarize in this. This is more high level summary. So the one thing I want to talk about this is to give you more visual understanding about the agent because I go into very technical detail in the other deck. The in the high level, when we talk about agent change, is we now agent can manage computers, right? We realize the tool calling is not just calling external tools, but manage controls your local laptop, and with that ability, they can organize things. And also, we introduce the so-called picture understanding. So that is also make the agent more powerful. The and also in the so-called the cost benefit well, for the company, that's the main that's the just the cost benefit. And so we have so-called deep research. Deep research agent is something I will cover in the future. It dramatically changed what an agent can do. So by introducing deep research agent, this is actually new. This is what I want to say in part of the trend in 2025 is the after OpenAI introduced the deep research agent, people realize agent become much more powerful by doing multi-step reasoning. And then there are many company like now Grok, now Gemini, all offers deep research. One thing, and I mentioned the Manus. Manus, because it's open source, it create a lot of excitement. The DR, I will show you a screenshot from my laptop. The DR is a local code, local agent. So instead of running on a website, it runs on your laptop. You can download. You can think about it. It has some privacy, but it what I realized is that kind of local running, essentially you still have to deploy to the cloud. So how much that privacy actually save is not clear. Because it's still remotely calling the LM still is in the cloud. So in the back end of it's just agent. It's still powered by LM doing reasoning, except it's running on your laptop. That's the only difference. But it's very interesting, very easy to use on the laptop. The Another trend last year, this is just introduced a few what's happening in 2025. OpenAI had an operator, then Google has the so-called Astra. Grok now has their own Grok agent. You can set up daily task. So essentially, the agent this is yeah. So this deck is more on the high level summary on what is happening, right? But let me see anything else. There's some specialized Salesforce, Google Ads, um, multimodal. Certainly, we mentioned um, multi-agent orchestration. I didn't go into detail. This could be one major topic we can talk about because many companies a struggle. Actually, it's not settled how we do multi-agent from Crew AI to AutoGen to even today's ADK. The ADK basically claims they support any kind of multi-agent configuration. You can have a centralized master agent and then sub-agent. You can have a parallel agent. Every agent is like can do things parallelly. They decided to do their own. They decided when to communicate back to the master agent. And then you have the so-called spin-off agent that dynamically invoke some agent, not pre-planned. You can have a diagonal DA the DAG tree, almost like a graph structure instead of a tree structure. So so those are the things. Yeah. So I will stop here for this deck. This is a very like high level summary about general things happening in the trend, but not a technical detail. This is just give you understanding about the major topic people talk about today. Um, for today's talk, I want to go a little deeper in terms of technical side. So let me get back to my slides. The okay. Yeah. So the technical detail, the two major topic I want to mention is building agent. We talk about the framework, we adopt the framework, but the most difficult part is prompt, writing the prompt. The prompt engineering, I think it's reaching its end, mainly because it's so manual. You really struggling. People are struggling with what prompt to update. Once you wrote something, it doesn't work. You have to change it. The We have to make it from ad hoc method, more like a software engineering approach to machine learning approach. So self-learning becomes by end of 2025, I believe it's the last 2 or 3 months of 2025 becomes a trend. And there are two major methods I want to introduce. I want to highlight. I believe maybe in the last few weeks there may be more methods coming out. We will review them if I get a hold of them. This JAPA was actually presented in October in another meetup, and I listened to the authors. Authors from UC Berkeley. They showed a very impressive result in terms of ARC, even all the major open data set. The result shows that with this kind of prompt updating method, they were able to write much shorter prompt and also have a much better performance than even GPT-5. So that means a excellent prompt. If you are learning how, you don't have to do model fine-tuning, you don't have to do reinforcement learning. Essentially, the whole paper, the JAPA paper, the central theme is that model updating for like open source model, your own model, it's certainly interesting, but it's not effective as you just use a large open source model and uh, do prompt updating or prompt learning on those large model. And so this, I believe for large enterprise, this becomes very useful because many companies don't care or don't want to do implement their own model or do a small language model, do fine tuning, learning on the models. Those are themselves is a different topic. So, so how does this how does JAPA works? Essentially, it's use kind of evolutionary method, so-called mutation and merging. Mutation basically is um, you mutate. So they divide the original prompt into several segments. So the way you mutate a certain segment of the prompt. For example, some segment talk about the role of the agent, the example of the agent, the basic rule of the agent, right? So you divide your prompt into several segments. Then they started to roll, they take a training data. They still need ground truth data. So they take a training data, but they iterate on, they don't need many training data. This is very different from reinforcement learning where you need a lot of training data to give you signal. Yes or no, right? The positive or negative. Probably thousands or tens of thousands of data. For JAPA, they mentioned they only need less than hundreds. The reason is that they use information beyond just good or bad. They use information on the human comments. So when they updated the prompt, they are reviewing what a human says, why the example, this particular case makes mistake. If it makes mistake, they process the human text together with the result and then feedback that into the LM to write the new prompt. So JAPA itself is still a agent that's driven by a large language model. So it's like large language model writing the JAPA algorithm for to improve another large language another agent. But think about the JAPA as an agent. Now this agent is has different components. As I mentioned here, is you do a rollout, you obtain the ground truth feedback, then you propose a new prompt. That's a mutation. And you do several mutations and later you do the merge. And the merge basically is there's some principle on the merge. They look at the trajectory of which part of the prompt has been mutated. So there's a tree they were tracking. On the tree, they check which give me the minimum the best improvement. And that improvement is described by the so-called Pareto principle, meaning every time I update, I merge a prompt, I should not decrease my performance. So minimally, I should perform as good as before, but improve in certain kind of subdirection. And so by using the Pareto principle, they were able to maintain performance, keep increasing. Yeah, so that's a so-called, yeah, great. Thanks for the link, sharing the link. The second method, which introduced a few months after, is called ACE. The title is Adaptive Context Engineering. This ACE is a very simple method. It's So basically, they said that there is a problem with the previous approach. Sorry, the previous approach. The previous approach um, basically rewrite the prompt. Each time they rewrite, the prompt actually keeps very short. The advantage of JPA is your prompt will not grow too big because by reflecting, by mutate, we actually can make the prompt very concise, very efficient. However, there is a problem of the so-called prompt collapse. Um, After many rounds, the prompt can become something very, very short and can maybe create some errors that cannot recover. Once you collapse, your next mutation, your next merge doesn't have a base, right? The base disappeared. So what ACE proposes is they don't want to disappear the base. They want to keep the original, the basic base. The basic base for them is the so-called play context playbook, or you can think about the PRD, a basic document that describe what the agent has to do, and that's their like blueprint. They start with a blueprint, the minimum blueprint they just add one by one to that original prompt. So they want to keep growing the prompt in the principal way. So how do they grow the prompt? Essentially, in the beginning, the prompt is very basic. They try to get the minimum prompt to start with. Then they have this, they load one example. So they have this trajectory. The example would lead you to certain kind of outcome, same as we did before. This is from training data. Then there is a so-called reflector, um, trying to reflect on whether this is the good prompt, right? So they have inside they keep refine self-reflection, we call this. So they have insight into how the prompt should be written. And after that, there is a curator who almost like a judge, the final judge to put together to basically combine the original ones with the final reflected prompt. And this become new, then they iterate this whole process with the next example and next example. The problem, okay, so they show very impressive performance against the JPA. So if you want to actually like adopt some prompt learning, prompt self-learning, I would say ACE is the one to go. They have the GitHub repo that it's open sourced, so you know exactly what they're doing. It's very easy to implement with this. The observations that because they do the growing, the prompt growing, the prompt does get very long. So it's a principal way to update your prompt, but also it's an expensive way to update the prompt. Then so there is a maybe at a certain point you need to re-optimize the whole prompt, and that has not been fully addressed by this methodology yet. Yeah. Okay. Very good. So now I want to move into context engineering. This is very abstract. The I need to yeah. Let me see. Ah, sorry. Okay. Um, So I mentioned that prompt engineering, even prompt self-learning, is still focused on the prompt. What the prompt give us is a good answer at every turn or good task, tool call, competition. Basically, prompt engineering is focused on executing, how to execute a task. The so we and now I'm doing the comparison between the prompt engineering and the context engineering. What the context engineering cares is how the agent acts in the whole life cycle in interacting with the user. So the user asks something, we execute something, the user keeps asking more, keeps modifying, give new instruction. So prompt engineering focuses on at every instruction, we should give user the right answer, the right um, execution, the right result. The context engineering is more about managing the whole user experience. And in order to manage the whole user experience, we are loading the user history. We manage the state. We call the session. Essentially, the state is in a browser environment is a session. So as long as a user in the session, you keep track of what the user has said before, what's the conversational history. So those and also the previous long-term history, right? So you want to also load the much longer history. You also have external data, so it's more dynamic in the another thing we have to worry is the context can grow when the conversation continue. So for example, user suppose it's an app building agent. The user build a beautiful app. And then the user say, I want to add some features. When they say that, you preload your state keeps all the previous modification of on that app in the memory, but that is a lot of tokens. Maybe the user change their mind, they change his or her mind to do something else, which has nothing to do with the previous two steps. So how do you reduce the number of tokens in the history and send the whole thing, whole requirement to the LM to give you back the result? That is a core. It's the most essential part of context engineering. And when we do this, we want to be reliable. We want to maintain the continuity, right? So this is all these are challenging, and there are many solutions being proposed. So I want to basically put this in a more visual, very visual way to understand how we actually work with context engineering. Essentially, it's this like a well that is it's a cycle. The cycle comes from loading when the user comes, you are loading the user history into the system. So that's what we call personalization, or what we call how to understand the long term was session. We start to manage the sessions. We started to basically get into this is a fetching phase, a phase of fetching information about the user. In the second phase, we do so-called preparation based on the user, what kind, and the user say something. We decide. We now load our static prompt. We load the use other information about the user. So in this preparation, we assemble the context and decide what to send to the LM. In the third phase, where the answer comes back, we decide what to do. So this is execution phase. After that, we finish the task for the user. We then need to summarize the information and then create not create a duplication with the like previous memory. The some every new entry into the our long-term memory needs to be reconciled with the previous record. So this is the so-called upload phase, and then the conversation with the user continues. So this is a loop. That is how we actually see the context engineering in action. Now the core question people ask is exactly how we minimize tokens. How do we reduce the length of like history? How do we know what to cut, right? So there are I think the methodology only become mature in the last I would say 2 or 3 months. There are some tutorials on this, but I want to just introduce, I believe the most recent principle technology. It's actually LangGraph has a tutorial on this. You can check out their tutorial. I highly recommend. I believe this is even though there Google also released their so-called white paper, but that white paper doesn't have a lot of core principle. The I would say the actual practical principle how to implement the context engineering, how to reduce context. So the three ways to reduce, and these are the three principles. Number one is offloading data. So by offloading, we mean, um, for example, if you have 100 tools to call, right? You don't write all the tools definition into your prompt. That this is what most people do. They say we have to define. Otherwise, how would my agent knows? How would my agent know what the tool to call if I don't have a definition? Or even MCP, I still need to define the initial tool calling. Um, you still have to define the initial tool calling. So the principle to offloading is you offload your memory in a kind of hierarchical way. You have a file that actually saves all the definition of tools. And then in your prompt, you only say, I'm going to refer to this file. It's like I have a reference. So it's like for the agent knows it has external memory in the file. So using file to track the agent tools, to track the agent even prompt themselves, the hierarchical prompt. So at the beginning, you just say, I only needed to understand what basic intent of this user is. After that, I'm going to load the file to say if intent is to dispute the transaction. Now I'm going to load the file that describe all the transaction tool definition. So those kind of offloading can reduce the memory of inside the context window. And secondly is reduce the noise. Reduce noise means basically is cut out a certain kind of history that you think is irrelevant in the conversational history. So that's the second part. Because the long too many you don't need everything from the history to tell you what needs to be done next. And with too long history that create noise. The third part is called isolating task. Isolating task is essentially a so-called multi-agent principle, where you, as I mentioned earlier, you have one agent that do some task. Maybe if you um, even for research agent, you have one agent to do search, one agent to do analytics, another agent to do summary. So those kind of isolating tasks allow each agent has a smaller context window. So that would help. All right, so that is pretty much on the content. I believe that's all. Yeah, that's that's the text summary. I want to show you two very interesting apps I built with Manus. I basically it's more about agent in action. Many of you probably already use agent. I want just to share my experience, and if other people already build a certain kind of agent, you can maybe we can share here. So let me get into my browser first. Where is my browser app? Um, Okay, here we go. Let me share my browser. All right. This is actually very new. I just tried out with Manus today. Think about the Manus. So Manus is Manus.im. It's they told you they're bought by Meta. It's a very simple command. What I want to build is an app that allow me to drop my video files to, and it does automatic merge for me. The oh, this is called API, but this actually already deployed. So what they I want to show you the code generation part. So they generate many code. The after I gave this command, they started to build out all the source code, and you can see the I show you. You can see all the code here. They were written, they write from front end to the back end, right? So certainly it's an app building, very but very fast, very efficient, very well, certainly this app is very simple. And then you can deploy. I can publish this. When I publish this, let me show you where my code is. Yeah, so I published it to this. It's a very clean app. People can upload the file and they immediately merge. Certainly, you can do more things. They do have like a LM, like a video transition. There are some additional features they we introduce, and you can keep modifying this app by giving more command. Once you give more command, this code will update. So you are basically sitting here with one sentence you generate an app for yourself to use. This is what we see going forward. Is app building becomes very simple. Um, yeah. So we don't need the so-called vibe coding. We don't need the coding. You don't even need the vibe coding certainly can also refer to building app, but typically, yeah, well, in vibe coding, this is vibe coding. Essentially, it's you are not writing any code. You are building an app. But this is become very mature. One more thing I want to share with you is our YouTube channel where I build a AI singer. You can think about this is oh, let me show you this. Directly go there. This is, can people hear the sound? Yeah, just unmute yourself. People say yes. Okay, good. Now, to build an app, AI singer, it's actually quite simple. I have a lot of ads here. Let me actually make this full screen. Now, to build the app, I use Grok to generate the image. And then I use AI songwriting software to generate the song. Then I use Infinite Talk to do the lip sync. So the result, it's, yeah. And you can see. Amazing grace, how sweet the sound that saved a wretch like me. Now, what I want you to notice is this is generated from a single picture. So there is no video. I didn't feed the video of the singing. The lip sync precision is so good that they can have the facial expression, they can have the lip moves, the make it very realistic, right? So the song, the music, even though it's a famous song, it's regenerated with AI, with this kind of different kind of merge from instrument, from singing. This is all AI generated voice, not the human singing voice. But it's very real, like real thing. Okay. All right. So that's my summary, and we are kind of running very